And the question a lot of people wonder is, so what is on the other side of that horizon, cosmic horizon?
That's an excellent question. We don't know for sure, but we have very good reason to believe we do know what's there.
Step into the cosmic revolution as the James Webb Space Telescope uncovers mysteries that challenge our understanding of the universe. In an unprecedented series of revelations, the Webb telescope has shattered the traditional Big Bang model, rewriting the cosmic narrative in ways that defy our expectations. These 10 latest discoveries aren't just scientific breakthroughs. They are cosmic adventures that inspire us to rethink the fundamental principles that govern the universe. From the discovery of strange galaxies that appear older than the Big Bang, to the mysterious dark matter and dark energy driving the expansion of our universe, each revelation is reshaping our fundamental understanding of the universe. So prepare to be thrilled by 10 amazing discoveries from the Webb telescope and learn how these discoveries are challenging what we know about the universe.
Decollage liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
Recently, scientists discovered many ancient supermassive black holes, which poses a major challenge for astrophysicists. One of these black holes is so strange that our theories completely fail to explain it. And scientists are claiming that this black hole may have formed before the Big Bang. In a paper published in Nature Astronomy, scientists reported the discovery of an ancient supermassive black hole, one that existed very early in life of the universe. While some enthusiasts have claimed that the observation of these gigantic black holes has disproved the theory of the Big Bang, our standard cosmological model, which is based entirely on observations and our physics theories, predicts that in the early universe, black holes were formed from the remains of massive stars. When these stars ran out of nuclear fuel, gravity caused their cores to collapse, creating incredibly dense objects called black holes. However, observations from the Webb telescope have unveiled a more diverse cosmic group. It has discovered a number of black holes that do not fit neatly into the expected story of stellar collapse. Some are surprisingly massive, challenging traditional views of stellar evolution. Astronomers were surprised when they found that the mass of this strange black hole at the center of the ancient galaxy was about the same as the total mass of the stars in that same galaxy. To put this into perspective, the supermassive black hole at the center of the Milky Way is only about 0.1% the mass of the entire galaxy. Given that this ancient supermassive black hole formed so quickly after the universe began, it cannot have been created by the collapse of stars and merging of stellar mass black holes. Instead, another mechanism is required. Sophisticated simulations have shown that early in the history of the universe, it is possible for giant clouds of gas to have collapsed directly into very large black holes, ones with masses about 100,000 times that of the Sun. But the James Webb telescope found other such ancient supermassive black holes at the very edge of our observable universe, which indicates that the direct collapse of dust clouds in the early universe would not be enough to explain this mystery. According to this model, our universe came into existence about 14 billion years ago, After that, an invisible force called dark energy started expanding our universe. As time passed, stars and galaxies formed and began to shape the structure of our universe. Dark matter, dark energy, and Einstein's gravity collectively weave the intricate tapestry of our cosmic evolution. Dark matter's unseen influence guides the formation of galaxies. Dark energy propels the universe's expansion, and Einstein's gravity provides the underlying framework that ties everything together. But recent discoveries by the Webb telescope have called these ideas into question. Recently, the Webb telescope has revealed the image of galaxy clusters that existed in the early universe. These clusters are the cause of the largest structure present in our present universe. The standard cosmological model beautifully explains how these galaxy clusters evolved, but there's a problem. It predicts that they're 7% more closely clustered together than they actually are. Well, this 7% difference is really huge because this difference can lead to major changes in our current model, such that the age of the universe can be completely different. To solve this problem, scientists use the most powerful supercomputer simulation that is based on the principles of our current physics. This time, scientists added the role of supermassive black holes in the evolution of our universe. But unfortunately, that's not right either. It's still 5% more clumpy. So, what's going wrong here? Why our most powerful supercomputer simulations fail to solve this mystery? Many scientists have proposed that if the best computer simulation ever created can't get the right result, then there are two possibilities. Either Webb telescope measurements are wrong, or our theories might be incorrect. Professor Carlos Frank believes that perhaps our way of understanding gravity is wrong. He posits that Einstein's theory of gravity may not effectively explain the evolution of our universe.
Well, according to Dr. Penrose, the universe needs an absolute value of the Hubble constant to exist, but for 50 years it has remained the biggest mystery in the field of astronomy, with scientists unable to find the real value that governs the universe. This discrepancy in the actual value of the Hubble constant is called the Hubble tension. There are two very different methods by which we can measure the value of the Hubble constant. Start right from the beginning, move the universe forward in time using the laws of physics, and then measure the earliest signals and their marks on the universe. This will tell us how it expanded over time. In this case, we use cosmic microwave background radiation as an early signal of the universe, and the value we get for Hubble constant is 67 kilometers per sec per megaparsec. Start from where we are now, look out at faraway things as they move away from us, and then figure out how the universe expanded from that information. In this case, we use a Cepheid variable star or supernova as the distance source. And here we get the value of Hubble constant as approximately 74 kilometers per second per megaparsec. Both of these ways use the same laws of physics, the same basic theory of gravity, and even the same equations. But when we actually do our observations and take important measurements, we end up with two completely different values that don't match up. This discrepancy in the value of the Hubble constant is called the Hubble tension. Scientists previously thought that the Hubble telescope might be giving us false information about the actual brightness of Cepheid variable stars due to dust in front of the stars. And scientists hoped that the Webb telescope would be able to better examine the stars and tell us the real value. Unfortunately, the Webb telescope showed that the Hubble tension is real, and the Hubble constant has no special value. No matter how we try to solve a problem, if everyone's way is correct, they should all end up with the same right answer. This rule applies not just to puzzles we make for each other on Earth, but also to the big mysteries that nature hides. So why there is a discrepancy in the value of the Hubble constant? To figure this out, scientists are coming up with new ideas about how the universe was in its early days, before that leftover radiation was sent out. They think maybe there's something like mysterious dark energy, or different kinds of tiny particles called neutrinos, or maybe even a way these neutrinos and dark matter interact. Well, we've already added dark matter and dark energy to the cosmic picture, and we're only now discovering that maybe that isn't enough to resolve the issues. Scientists have recently claimed that our current model has some major shortcomings, and the answer to this question lies beyond the Dark Ages.
Recently, a research team has discovered two new most distant confirmed galaxies in Webb telescope new deep field image. Now the number of confirmed galaxies has surpassed any prior theoretical predictions made before the launch of the Webb telescope. These four standard theoretical models consider different values of dark matter content in the universe to achieve computer-generated simulations of galaxy formation. But recently discovered galaxies have proven all four models wrong. The research team led by Yuichi Harikon, assistant professor at the Institute for Cosmic Ray Research, the University of Tokyo. For the first time, they made precise measurements of distant galaxies discovered by the Webb telescope. Because countless galaxies from 13.4 to 13.6 billion years old have been discovered by the Webb telescope. However, these objects are candidates for distant galaxies discovered from images, and determining their exact distances requires detailed analysis through spectroscopic observations. For instance, Sears 93316, reported as a galaxy candidate from 13.6 billion years ago last summer, was later determined through spectroscopic observations to be a galaxy from 12.6 billion years ago. Recently, the team led by Harry Kane deeply analyzed spectroscopic observational data obtained through the James Webb Space Telescope. Using this method, they discovered the two most distant galaxies whose exact distances were 13.40 and 13.42 billion light-years respectively. In the most distant universe, 13.4 to 13.5 billion light-years away, three galaxies had previously been confirmed through spectroscopic observations, with uncertainty prevailing regarding whether these findings contradicted theoretical predictions. With the addition of two new galaxies confirmed by the team, a total of 5 galaxies have now been identified in the early universe, dating back approximately 300 to 400 million years after the Big Bang. But the surprising thing is that the discovery of these 5 galaxies was not predicted in any theoretical models published before the launch of the James Webb Telescope. Professor Yuichi Harikane said, "Before the launch of the James Webb Space Telescope, large telescopes like the Subaru and Hubble were used to study distant galaxies, and their results were well explained by various theoretical models. However, the discovery of these 5 galaxies in the most distant universe by the James Webb Space Telescope was unexpected in any of those theoretical models. Scientists are saying that there could be more candidate galaxies in this era. The real count might further increase. Astronomers are facing a new challenge with these discoveries. They're observing a huge population of early galaxies just a few million years after the Big Bang. All this raises serious questions about our understanding of the evolution of galaxies. As you can see here, the record for the most distant galaxy before the Webb telescope was held by the distant galaxy GNZ11, discovered by the Hubble telescope. It existed just 400 million years after the Big Bang, when the universe was only 3% of its current age. It belongs to the first generation of galaxies in the universe. But the Webb telescope's early observations have broken the record for the most distant galaxy, with scientists recently confirming 4 most distant galaxies that are even older than the most distant galaxy seen by the Hubble telescope. One of these galaxies, named GSZ13, became the most distant galaxy ever observed, galaxy Jade's GSZ13 was imaged by Webb as it was 325 million years after the Big Bang. This most distant galaxy is now estimated to be 33 billion light-years from Earth due to the expansion of the universe in the time since the light that has just reached Webb left the galaxy. But when scientists looked at the new observational data, they were stunned. No one expected that we would see something like this. Scientists noticed that many early galaxies beyond the edge of the early universe suddenly appeared in this data. Peter Van Dockum, an astronomer at Yale University not involved in the latest research, said that the Webb telescope has observed possible galaxies even closer to the Big Bang, but they have yet to be confirmed. However, some of the candidate galaxies, if confirmed, would have existed when the universe was less than 200 million years old. Scientists say what this data is showing is actually a big problem for our standard cosmological model. This huge population of galaxies near the Big Bang brings more questions for us to solve. Our standard cosmological model, which is based entirely on observations and our physics theories, predicts that there should be an order in the evolution of early galaxies. This means, as we look deeper into the early universe, there should be less organized and smaller young galaxies. But unfortunately, recent observations from the Webb telescope show that some galaxies in the early universe are more organized and more massive than expected. Also, some early galaxies are exceptionally complex and massive, like our Milky Way. This discovery poses a serious challenge to our understanding of how stars and galaxies formed in the early universe. Even Nobel laureate Dr. John C. Mather, senior project scientist for the Webb telescope, was stunned by this recent discovery.
We are looking farther back in time than we could before, and we are really thrilled with this picture. We have been working on the story of how the galaxies grew. I told you we were going to see the first ones growing, and we saw some, and they were a big surprise. They were bigger, brighter, hotter than we expected. And some people said, well, then our whole story of the expanding universe might be wrong. And I think more likely our story of how the stars grow is wrong.
Here's a galaxy called Sears 2112 as seen by the Webb telescope a few million years after the Big Bang. Scientists say that the size of this galaxy is almost similar to our galaxy. The existence of such galaxies, like our Milky Way just few million years after the Big Bang, poses a major problem for our standard cosmological model. Astronomers thought barred spiral galaxies such as the Milky Way didn't appear until the universe reached at least half of its current age, because it was believed that it took several billion years of galactic evolution before the massive collections of stars within galaxies could form central bars. Astronomers previously thought this galactic structure marks the end of a galaxy's formative years, so it was expected to be seen only in old galaxies that may have reached full maturity, perhaps those that existed halfway through the evolution of the universe. Indeed, the Hubble Space Telescope's past observations of galaxy morphologies have shown the early universe hosted very few barred galaxies. However, the new findings, gleaned from data by the James Webb Space Telescope, conclude it may not be necessarily true that barred spirals must have roamed the universe for so long. The discovery of spiral galaxy, Sears 2112, reveals galaxies that resemble our own already existed 11.7 billion years ago, when the universe had just 15% of its life. Over billions of years, galaxies underwent remarkable transformations through processes like mergers, collisions, and the formation of new stars. This evolution, observed through telescopes, shows how galaxies have changed in size, shape, and composition. The intriguing aspect is that this evolution isn't just random, it's a continuous learning process. but the discovery of Sears 2112 has suggested that this evolution only took about 1 billion years or less. Well, the existence of these impossible oldest galaxy candidates in this Milky Way-like galaxy, a few billion years after the Big Bang, is a serious challenge to our theories. Are we missing something in our galaxy evolution models, or are we completely wrong about the early universe and its origins? Astronomers have been left baffled by the discovery of heavy elements in distant teenage galaxies that are far younger than previously thought possible. These galaxies, which formed just 2 to 3 billion years after the Big Bang, are unusually hot and contain elements like nickel, which are typically only produced by massive stars that explode as supernovae. Alison Strom, an assistant professor of physics and astronomy at Northwestern University and lead author of the study, says, "Never in my wildest dreams did I imagine we would see nickel. Even in nearby galaxies, people don't observe this." The presence of nickel was particularly surprising, as it is a heavy element that is rarely seen in young galaxies. Nickel is produced when massive stars collapse and explode, releasing a burst of radiation that heats up the surrounding gas and dust. This process is thought to take billions of years to occur, so it was not expected to be seen in galaxies that are only a few billion years old. While the lighter elements were expected, the presence of nickel, which is heavier than iron in the periodic table, came as somewhat of a surprise. The discovery of nickel in these teenage galaxies suggests that they may be forming stars at a much faster rate than previously thought. This could explain why they are so hot and why they contain such a large amount of heavy elements. But we still don't know what exactly accelerated the process of star formation in the early universe.
In recent images, astronomers found that a giant galaxy that is much larger than our Milky Way and a galaxy that is too small to exist are both located in the same place in the early universe. And this discovery created a stir in the field of astronomy like never before. Recently, astronomers have also discovered a galaxy that has started forming stars at a high rate, just 500 to 550 million years after the Big Bang. The radius of this galaxy is only 16 parsec, and this is where the real problem comes in. This galaxy is so small that we have never seen such a small galaxy before, and it is forming stars at such a high rate that it is absolutely impossible. So, what is this? Is it a galaxy or something we have no idea about?
Joel Leja, assistant professor of astronomy and astrophysics at Penn State University, says, "We expected only to find tiny, young, baby galaxies at this point in time, but we've discovered galaxies as mature as our own, in what was previously understood to be the dawn of the universe." When some scientists took a closer look at these galaxies, they found that some of these galaxies were not only larger and more organized, but surprisingly they started forming stars earlier, making current theories more suspicious. Here's what astronomers say about this unexpected discovery. Nobody expected them, they were not supposed to be there, and now nobody can explain how they had formed.
Recently, some astronomers revealed that they have discovered a black hole which is the most distant black hole ever discovered. This black hole is nearly 500 million years after the Big Bang. And they also found that, like Webb's early galaxies, this black hole shows unexpected properties that don't comply with our existing models. This black hole is showing rapid growth only a few million years after the Big Bang. The scientists said, this black hole is showing unusual growth, and this is impossible with current understanding. This black hole is about 10 million times more massive than our Sun, so it's actually a medium-sized black hole. But still, this black hole must have needed an external boost to be so big. If we look at the current model, then this black hole looks older than our universe.
The discoveries made so far by the Webb telescope have broken the traditional limits of our cosmological models. Galaxies of unexpected size and strangeness have emerged from the depths of cosmic antiquity, defying our expectations and stretching the limits of our knowledge. These massive and mature galaxies pose a serious challenge to our established theories and force us to re-evaluate the foundations on which our understanding of the universe rests. These findings have shown us that the start of the universe might be much more complicated than we previously thought. We have to rethink our ideas and explore new possibilities. It's an exciting time for scientists all over the world as they work together to understand these new mysteries and come up with new explanations for how the universe began. Well, maybe in the future the Webb telescope will reveal how the entire universe came into being. Until then, we are on a journey to unravel the mysteries of the universe with our powerful telescopes.